We can solve quadratic equations using many different methods, and it just depends on what your equation looks like, how it's set up, as to which method is better than another. We're going to look at solving using square roots and completing the square in this video. If you haven't looked at the completing the square in general video, you should probably go back and do that, because we're going to use all of those techniques and skills in this video without a lot of underlying information. I'm going to assume you know how to do that. So solving using square roots, we need to start out with a quick, easy example. Let's look at x squared equals 25. If I were to ask you to solve this equation for x, you could actually do it using your do and undo method. What's being done to x? Well, it got squared, so we need to undo squaring, and undoing is taking the square root of both sides. So we get x equals, now here's where it gets a little bit tricky. X equals 5. But x could also equal negative 5, because think about it. If I had negative 5 squared, would that equal 25? It would. So whenever we take the square root of both sides, we have to remember that it is plus or minus whatever that square root is. So x has two answers. X equals 5 and x equals negative 5. So the solutions to this quadratic problem are 5 and negative 5. That means the x-intercepts are 5 and negative 5. So that's just solving using square roots. Pretty not too bad. You isolate the x squared term and you take the square root of both sides. This quadratic could actually be solved in a bunch of different ways, but since we're looking at solving with square roots, let's do it that way. We want to isolate the x squared term, so we're going to add 4 to both sides. So we get x squared equals 4. Now our goal is to get x by itself, so we need to take the square root of both sides. And remember, x equals plus or minus the square root of 4, which is 2. So our two answers are x equals 2 and x equals negative 2. You can leave your answer as x equals plus or minus 2 if you want, but I just wanted to emphasize the fact that we have two solutions. There are two x-intercepts to this quadratic. I have a little bit of extra room on this slide, so I'm going to do another example. Let's look at 2x squared plus 7 equals 63. Our goal is to solve for x, so we need to get x by itself. There's a little bit more to do in this problem. First thing I'm going to do is subtract 7 from both sides. So we're going to end up with 2x squared equals 63 minus 7, which is 56. Well, now we have to divide both sides by 2. So we're going to end up with x squared equals 28. Now we're going to undo the squaring, so we're going to take the square root of both sides. So I'm going to move up here. X equals plus or minus the square root of 28, because that's not a perfect square, so it isn't nice like the other one. However, think back to simplifying with square roots. We can simplify this answer a little bit. 28 is the same as saying the square root of 4 times 7. So that 4 can escape. So our final answer is x equals plus or minus 2, because that's what 4 escapes and becomes, times the square root of 7. And that would be our final solution. Again, I just want to emphasize that this is 2 times the square root of 7 and negative 2 times the square root of 7. There are two answers to this. A lot of times quadratics will have two answers. They can have 0, 1, or 2, but 2 is one of the most common. I wanted to throw this equation in there because we're going to be solving using square roots for a lot of your physics problems. And this is an example of something you might see in physics, and you're going to get some gross numbers, but that's okay. We will use decimals on this one. So the first thing I need to do is isolate the variable. So in this case it's t, so we're going to subtract 200 from both sides. That leaves us with negative 4.9 t squared equals negative 200. Okay, now we need to get the variable by itself, so we need to get rid of that negative 4.9, and so we're going to divide both sides by negative 4.9. So So we're going to end up with t squared equals, now let's do negative 200 divided by 4.9 right now, and that way we'll have a decimal. We know it's going to be a gross answer anyways. 40.82 is what I got. Check my math. Okay, now what we need to do is take the square root of both sides. So we're going to get t equals plus or minus. Now, when you take the square root, there's a couple ways you can take the square root. You can, on your telephone, turn it sideways, and that'll get you your square root. You can use the Google calculator. It has a square root on it. You can use an Inspire if you have one of those. There's lots of different ways for you to do that, but we're going to find the square root of 40.82. It's going to be about 6.38 or 9, depending on how you round it. Now, if this were a real physics problem, like it was a situation that we were looking at, we wouldn't necessarily want to consider both answers. More often than not in physics, you're only worried about the positive answer, because in this equation, t stands for time, and we're not going to be focusing much on the negative time. However, mathematically, you do still have two solutions. This is sort of our stepping stone into solving using square roots, which is what we're going to do next. This one is set up, it looks kind of like vertex form. But we can solve this by taking square roots eventually, because we're going to have to get rid of that squared. So I'm going to go ahead and attempt to isolate x. So I'm going to add 12 to both sides. So that leaves us with x minus 2 squared equals 12. Now, our goal is to always liberate x, get x by itself, and right now it's in those parentheses, and those parentheses are getting squared. So we can take the square root of the whole set of parentheses to undo that. So now I have x minus 2 equals plus or minus the square root of 12. Okay, now we need to get x by itself, so I'm going to add 2 to both sides. That leaves us with x equals 2 plus or minus the square root of 12. And we can actually simplify the square root of 12, because that's 4 times 3. So we can actually write our final answer as x equals 2 plus or minus 2 times the square root of 3. I know you're thinking, oh my gosh, that answer looks really weird. What exactly does that mean? Well, this means that 2 plus 2 times the square root of 3 is one answer, and 2 minus 2 times the square root of 3 is another answer. You can get the decimal forms of these equations by typing them into your calculator, the decimal forms of these numbers by typing them into your calculator. However, for here, it just makes sense. We were able to do this problem without a calculator by just leaving it in radical form like this. No matter what you do, I don't care. It all really just depends on the situation. So here we have a problem where we have x squared and we have x. We can't solve using square roots if we have more than one x. So what we need to do is we need to complete the square. That's a way for you to write it with only one x. So think about what we did when we completed the square. We moved whatever was not an x over to the other side. We're going to do that again. So we'll look at x squared plus 2x equals 48 minus 6. Now remember, we're going to have plus something, so I'm going to write my plus something right there so we can get our completing the square trinomial set up. Now we're going to have x, and here's where b divided by 2 comes in. B divided by 2 is 1, all squared is 1, and since we didn't have to deal with factoring out any a's, we also added 1 to the other side as well. So we have x plus 1 squared equals 48 minus 6 plus 1. So I think that's 43. Now, if we look at what we have after completing the square, we have a problem just like the last one we did. We need to liberate x. We can take the square root of both sides. So we get x plus 1 equals plus or minus the square root of 43. I don't think any perfect squares go into 43, so I'm just going to leave it like that. We do need to deal with that 1 and move that to the other side by subtracting. So you get x equals negative 1 plus or minus the square root of 43, and you're done. You don't need to put it in decimal form. We can leave it in radical form for now. Remember that this is really two solutions. This is x plus the square root of 43. Sorry, negative 1 plus the square root of 43, and negative 1 minus the square root of 43. Just going to do a couple more examples to remind you about how to complete the square, what we look for when we solve using complete the square. Complete the square, always put our x terms together. And we have to complete the square on this one, we know, because we have more than one x term. We have an x squared term and an x. So to complete the square, we need to gather all of our x's and put everything else on the other side of the equation. To do that, I'm going to add 12x to both sides, and I'm going to add 5 to both sides. So I end up with the equation 3x squared plus 12x equals 5. These guys canceled, and I added those to both sides. Now I'm going to solve this using complete the square, so I need to pull that a out, and then I need to get ready to add my something. So when we factor out a, we're going to be left with x squared plus 4x, and then plus something, remember, equals 5 plus something. We always don't want to forget that. Now our goal, remember, is to write this as something squared. So to do that, we're going to do b divided by 2, all squared. And then this was one where we pulled out a. So remember, we did not just add 4 to that side. We added 3 times 4, which was 12. That's what we need to balance the equation with. So that means our right-hand side is 17. Now we have 3 times x plus 2 all squared equals 17. Can't take the square root of both sides yet. I need to divide both sides by 3. So we get x plus 2 squared equals 17 over 3. I don't want to use the decimal. That means I have to get a calculator. I'm just going to go ahead and leave it in fractional form. Let's take the square root of both sides. So we get x plus 2 equals the square root of 17 over 3, and plus or minus. One last thing to do is to move that 2, so we're going to subtract 2 from both sides. So we get x equals negative 2 plus or minus the square root of 17 over 3. I'm just going to go ahead and leave our answer like that. I'm not asked for a decimal approximation, so this would be the exact answer. Remember, that's 2 answers. It's negative 2 plus the square root of 17 over 3, and it's negative 2 minus the square root of 17 over 3. Here's the last one I want to look at for solving using complete the square and square roots. Again, I know I need to complete the square on this one because I have 2 x's. If I only had an x squared term, then I could go ahead and just use the square root. Since I don't, I'm going to have to do a little bit of extra work. It looks like I'm also going to have to factor out a. Since the 40 is already on the other side of the equation, we're good there. So I'm going to go ahead and start by pulling out the a. So we get x squared minus 2x plus something equals negative 40 plus something. Now we need to find that something. And to find that something, we're going to think about what our completed square is going to look like. B divided by 2. All squared. Did you really just add 1 to that side? No, we added 2 times 1, which is 2. So that leaves me with negative 38 on that side. Okay, now we need to divide both sides by 2 in order to be able to take the square root of both sides. So we get x minus 1 all squared equals negative 38 divided by 2, which is negative 19. Now we take the square root of both sides, and we get x minus 1 equals plus or minus the square root of negative 19. Square root of a negative number, this is something we talked about earlier. Square root of a negative number means that I have an I. This is an imaginary number. That's okay. So this is really like saying x minus 1 equals plus or minus I times the square root of 19. Add 1 to both sides, and I'm going to put it over here to the left. I get x equals 1 plus or minus I times the square root of 19. I still have two solutions. I have 1 plus I square root of 19 and 1 minus I square root of 19. But both of these are complex solutions to my problem. So solving with square roots and solving with complete the square both involve trying to take the square root of both sides. So you need to either isolate the x term in the square root case or isolate the x in parentheses part in the complete the square case, take the square root of both sides, and then finish isolating x.